Hello and greetings to everyone. Today we are going to start with topic 4, abbreviated as T subscript 4, number basis. Most often we usually do our counting in groups of a particular number. For example, when we make use of the word a dozen, we always think of 12 things. When we hear the word a score, we think of 20 things. For example, a very simple example, in a week, we know a week is made up of 7 days. A month is made up of 4 weeks. All these examples I've just listed, you'll discover that counting is done in groups of a particular number. All these examples cited, they are applications of number basis. Now let's take down this question. What is a number base? What is a number base? When we talk of a number base is an idea of counting in groups of a particular number. Take for example, if we have 14 days, we can decide to count the 14 days in groups of 7 days. And we know 7 days will give us a week. If we are given 14 days, we know we have 2 weeks. Let's write down some examples. For example, cite the first one. 7 days, we know 7 days make a week. That's an application of a number base, counting in groups of 7. 2, we know 4 weeks make a month. Next, we know 12 things make a dozen. These are examples of real life situations where number bases are applied. Also, in the Hindu-Arabic numeral system we earlier treated, it is built up in the idea of counting in groups of tens. This system of counting in groups of tens is called the denary or the decimal system. So you take note of that. Now let's take down the next subheading, which is the denary or decimal system. So you can either make use of denary or you make use of the word decimal. Represent the same thing. Let's write this down. This is a system. This is a system of counting. This is a system of counting in base 10. When we talk of base 10, that means we count in groups of tens. Counting in groups of tens. In this system, we make use of 10 symbols. Make use of 10 symbols called digits. We saw this under the Hindu-Arabic numeral system or digits. That is, these are the 10 symbols we make use of. We make use of 0, 1, 2, 3, 4, 5, 6, 7, 8, and lastly 9. All other numbers are built using the 10 digits above. Let's take for example in the number 934. In this number, let me underline it, 934. The digit, take the first digit with the highest place value, the digit 9 stands for 90 groups of tens, the digit 3 stands for 3 groups of tens, and the digit 4 stands for 4 units. That's for 4 units. Next, let's take now the next heading. Under this, I'll prefer to call this one I. This is I. I is the binary or decimal system. Let's take subheading. Under this, we have the expanded form of decimals. Expanded form of decimals. When we talk of expand, when we hear the word expand, that means to open up something. A decimal, let's write this down. A decimal number is said to be in expanded form when it is written as a sum of its units, tens, hundreds, thousands, and so on. If the highest place value of that number is thousands, then you start from thousands, right? You end at units. If the highest place value is millions, you start from millions, then you end at units. Let's take an example on this. Example. Goes write the following numbers. Write the following numbers in expanded form. The first one, A, we have the number 5231. B, we have the number 134,292. Let's take solution. We take the first number at 5,231. We have to write this number in expanded form. We know 5 here, the digit 5 has a value of 5,000, plus the digit 2 has a value of 200, plus the digit 3 has a value of 30, plus the digit 1 has a value of 1 unit. Next, we know 5,000 is the same as 5 times 1,000. That means when you add 1,000 5 times, you obtain 5,000. Plus 200 is the same as 100 plus 100. When you add 100 2 times 100, plus 30 is the same as 3 times 10, plus we know 1 here can be written as 1 times 1. There's a reason why we are doing this. We have written this number in expanded form. Next, let's go to B. B, we have the number 134,292. We know 1 here has a value of 100,000, plus 3 has a value of 30,000, plus 4 has a value of 4,000, plus 2 has a value of 200, plus 9 has a value of 90, plus 2 which has a value of 2 units. We know 100,000 can be written as 1 times 100,000, plus 30,000 can be written as 3 times 10,000, plus 4,000 can be written as 4 times 1,000, plus 200 can be written as 2 times 100, plus 90 can be written as 9 times 10, plus 2 here can be written as 2 times 1. Means when you add the number 1 twice, you obtain 2, the 2 units. Next, as a way of minimizing time and space, we make use of the following. Notations in writing powers of 10. When I talk of powers of 10, in this case, I'm simply referring to 1 with zeros. I have the number 1, 10, 100, 1000, 10,000, 100,000, 1,000,000, and so on. Next, if we have the number 1, number 1 here, you see 1 has no 0. In index form, we write it as 10 to the power 0. That means when you have a 1 with no 0, you write it as 10 to the power 0. When you have 10, 10 is written as 10 to the power 1. 100, 100 is the same as 10 times 10 is simply equal to 10 to the power 1, 2. Next, 1000 is equal to 10 times 10 times 10 is simply equal to 10 to the power 1, 2, 3. You can see 1000 has 3 zeros. Next, 10,000 is the same as 10 times 10 times 10 times 10, which is simply equal to 10 to the power 1, 2, 3, 4. You can see 10,000 has 1, 2, 3, 4 zeros. And so on. When you see 10 to the power 5, 10 to the power 5 is 100,000. That means 1 with 5 zeros. If you see 10 to the power 6, it is 1 with 6 zeros. Take note. An expression, let's take note of this, an expression of the form, alright, with the red pen, it is very important, e to the power n. That's how we read it. E to the power n is said to be in index, form. Index form with e, this e called the base, and n called the power, or exponent. Take note of these names. Or index. When you hear of indices, it is a plural form of index, or logarithm. These four names here, they are all referring to one person. Let's take for example, e.g. 10 to the power 5. This is a number in index form. 10 is the base, 5 is the power. You have 10 to the power 3 is in index form. 2 to the power 4 is in index form. 3 to the power 12 is in index form. These are all numbers in index form, so you take note of that. Next, let's take an example. Let's take example this. By using the index notation, write the following numbers, following decimal numbers in expanded form. The first one, A, we have the number 531. B, we have the number 134,000, the same numbers we had above, 292. Take now solution. Here we have the number 531. We know 5 has a value of 500, plus the digit 3 has a value of 30, plus the digit 1 has a value of 1 unit. You know this is the same as 500 is the same as 5 times 100, plus 30 is the same as 3 times 10, plus 1 is the same as 1 times 1. This is simply equal to 5 times, we know 100 in index form is simply the same as 10 to the power 1 to 100 has 2 zeros, 10 to the power 2, plus 3 times 10. We know 10 in index form is simply 10 to the power 1, plus 1 times, we know 1 in index form is simply 10 to the power 0. We are done. We underline our solution. Next, we go to B. B, we have the number 134,292. You know the digit 1 has a value of 100,000, plus the digit 3 has a value of 30,000, plus the digit 4 has a value of 4,000, plus the digit 2 has a value of 200, plus the digit 9 has a value of 90, plus the digit 2 which has a value of 2 units. You know, you can write this down as 1 times 100,000 plus 3 times 10,000 plus 4 times 1,000 plus 2 times 100 plus 9 times 10 plus 2 times 1. This will simply be equal to, we know 100,000 in index form is simply 10 to the power 1, 2, 3, 4, 5. 10 to the power 5 plus 3 times 10,000 in index form is simply 10 to the power 1, 2, 3, 4. plus 4 times 1000 in index form is simply 10 to the power 3. Has 3 zeros, plus 2 times 100 in index form is simply 10 to the power 2, plus 9 times 10 in index form is simply 10 to the power 1, plus 2 times 1 in index form is simply 10 to the power 0. We are done with the solution, and this is our result. We are done with this. Next, we are going to take now a subheading, which is condensed form of decimals. Condense. When you hear of condense, that means reducing something. Condensed form of decimals. Decimal numbers. Decimal numbers written in expanded form. That means when we are given we can be given a decimal number which has been written in expanded form, and we can go back to the original decimal number. Let's write this down. Decimal numbers. Decimal numbers written in expanded form. Can be simplified to get back the original number. Let's take example. Simplify the following. Here we have the number 1 times 10 to the power 3 plus 4 times 10 to the power 2 plus 8 times 10 to the power 1 plus 9 times 10 to the power 0. For B, we have the number 6 times 10 to the power 5 plus 2 times 10 to the power 2 plus 1 times 10 to the power 0. We take down solution. A, we have 1 times 10 to the power 3 plus 4 times 10 to the power 2 plus 8 times 10 to the power 1 plus 9 times 10 to the power 0 is to simply be equal to 1 times, we know 10 to the power 3 is simply 1 with 3 zeros, 1000, plus 4 times 10 to the power 2, 1 with 2 zeros, 100, plus 8 times 10 to the power 1, 1 with 1 zero, which is 10, plus 9 times 10 to the power 0, simply means 10 to the power 0 is simply 1. This will be equal to 1 times 1000 remains 1000 plus 4 times 100 gives us 400 plus 8 times 10 80 plus 9 times 1 9. Next we have to add 1000 plus 400 gives us 1400. 1400 plus 80 gives us 1480. 1480 plus 9 gives us 1489. We are done. Next we go to B. We have 6 times 10 to the power 5 plus 2 times 10 to the power 2 plus 1 times 10 to the power 0. This is simply equal to 6 times 1 with 5 zeros, that is 100,000, plus 2 times 10 to the power 2, 1 with 2 zeros, 100, plus 1 times 10 to the power 0 is simply 1. This will give us 6 times 100,000 gives us 600,000, plus 2 times 100 gives us 200, plus 1 times 1 gives us 1. Next we have to add 600,000 plus 200 plus 200 gives us 600,200 plus 1, it gives us 600,201. 600,201. This is the result. Next we are going to end with the exercises for application on this. Exercises for application. Question 1. Give two names. Give two names for base 10. Question 2. List all the digits. List all the digits used in base 10. 3. Write the following numbers. Write the following numbers in expanded form, making use of index notation. The first one, we have the number 20,001. Next we have 111,111. Next we have 100, 1,300,062. Lastly, the 9,840,671. Question 4. Simplify following the following expanded numbers. Here we have 6 times 10 to the power 3 plus 1 times 10 to the power 2 plus 5 times 10 to the power 1 plus 8 times 10 to the power 0. For B we have 6 times 10 to the power 4 plus 7 times 10 to the power 0. C we have 1 times 10 power 5 plus 3 times 10 power 2 plus 7 times 10 to the power 1. D we have 2 times 10 to the power 7 plus 4 times 10 to the power 5 plus 5 times 10 to the power 3 plus 3 times 10 to the power 2 plus 9 times 10 to the power 0. So these are the exercises for application we have on this. Next, we are going to correct these exercises before we move to some other cases. If in case there are any questions, make sure you leave your questions at the comment section. Thank you very much for watching.